The focus of this lesson is on determining the inverse of a function along with finding the domain and range of the function and its inverse. So the process for determining the inverse is basically you start off and you rewrite your equation so it says y equals, and you swap your y and your x's. You interchange all of them. So if there's an x, you put a y. If there's a y, you put an x. And then you solve for your new y, and that result is your f inverse function. So, and then the domain of your original function is the same as the range of f inverse. And the range of your original function is the same as the domain of its inverse. So in order to find the inverse, a function has to be one-to-one. So we're starting off with this function f of x equals x squared plus 1, but notice there's a restriction. X has to be less than or equal to 0. And actually I'm going to just kind of graph f of x equals x squared plus 1 just to give you some perspective. So all that is f of x equals x squared shifted up 1 unit. So if we'll go 1 unit up, that puts its vertex here. So I'm just kind of rough sketching pretty fast here just to kind of give you a perspective. So this would be f of x equals x squared plus 1, but we have the added restriction that x is less than or equal to 0. So with that in mind, we're only looking at from the vertex to the left of the y-axis. So our graph is just what we have in pink. So from here over. And that's who we're trying to find the inverse of, f of x equals x squared plus 1, where x is less than or equal to 0. So we're going to go ahead and work through that process now. So where there's an f of x, write y, and then so it's y equals x squared plus 1, where x is less than or equal to 0. And then what we're going to do is where there's a y, put x, and where there's an x, put y. And that's everywhere there's an x. So this says x is less than or equal to 0. I'm going to change it so it says y is less than or equal to 0. And then what you do, this is the hardest part of the process, is you have to now solve for your new y. So I'm going to go ahead and subtract 1 from both sides, which gives me x minus 1 equals y squared, where y is less than or equal to 0. I'm going to change the order so I can kind of look at the y squared equals the x minus 1, where y is less than or equal to 0, so I haven't changed anything. I'm going to apply the square root to both sides to get rid of that square. When I do that, that leaves me the absolute value of y is equal to the square root of x minus 1, where y is less than or equal to 0. But then that means y is either positive or negative square root of x minus 1. But we're saying that y is less than or equal to 0, so y is either negative or 0. So notice the positive part couldn't work here because we have to be negative or 0 if y is less than or equal to 0. So at the end of the day, we're left with our inverse being, so I'm going to rewrite it with that right notation, f inverse of x is negative square root of x minus 1. Notice the graph of f inverse would reflect across the line y equals x. So you can see in purple here we have f inverse of x, and in pink we have our f of x. So if we talk about the domain of f, so this is in terms of f of x we'll start off with. If we talk about the domain, we can see that it goes from negative infinity up to 0, but not going past, but it does include, so we put a bracket. And we can see that the range, which is our y values, starts at 1 and goes to infinity. But when we talk about f inverse of x, we can see that the domain starts at 1 and goes to infinity. And then the range, if we think about that, the range would start at negative infinity and go up to 0. So notice that the domain of f is the same as the range of f inverse, and the range of f is the same as the domain of f inverse. And that will always be the case as inverses swap ordered pairs. And again, their graphs reflect across the line y equals x.